Hey guys, here's Alex and welcome back to my video series on solving LeetCode problems. In this video we're solving problem 1926, the nearest exit from the entrance in the maze. I'm going to explain what it is instead of reading this. You're in a maze and you start at this position, for instance. So they tell you which position you start. And you could either go one step up, one step down, one step left, one step right. If there's not a wall, of course. You want to escape the maze. So you can escape the maze by going to a position that's on the edge of the map. Like this one, or this one. But you cannot cross walls and you can only go one step at a time. So you can get here and you can get here. They want you to tell you what is the minimum number of steps, like the nearest path to the exit. In this case, it's 1. Output 1, so you just go one step up. In this case, well, you start next to an exit, but in this case it doesn't count. You need to go all the way to the other point. So 1, 2. And in this case, well, you start at an exit place, so it doesn't count, but you can't really go anywhere else, so output is -1. So how do you solve it? So you can solve this with a breadth first search or a depth first search. And what is that? Basically, you're on a maze, and I'm going to draw a maze for you right now. And you start here, and all of these blocks here are walls. And you will want to go from this place to one of these two. Oh, sorry, didn't want to do this. Oh, I get it. I see what's going on. So it didn't really do this. Yeah, done. So you want to go from this place to this place or this place. We can clearly tell that this place here is the shortest path. But how do we find out? So what we do is we just visit the neighbors. So we're here, and let's just name the positions quickly so it's easier to explain. So we are position 1. So actually, we start with a first in, first out list of position 1 with 0 steps. It took you 0 steps to get to position 1. So you visit it, and the first thing you do, the first thing you do is create a wall. If you put something here on the FIFO, you create a wall there. So now you add the neighbors, and the neighbors are 2. And how many steps you need to get there? You need to get there 1 plus the steps you need to get to 1. So it's 1 plus 0. And you also can get to 7. So it's 7, 1 step. Okay, so now let's visit 2. If we are visiting 2, and also 7. If we're visiting these 2, we just add them to the FIFO, so we need to build walls. Now we visit 2, and let's add the neighbors of 2 to our FIFO. So let's add 3, and the number of steps is 2, and 4, number of steps is 2. And once again, let's build walls. So now we go to 7, and we add 8, but 8 is 1 on the edge, so we just return the number of steps, and that's it. We know for a fact that the first exit that we'll come across will have the minimum number of steps to get there. If you were planning on doing another approach like the depth first search, you can also do it. However, you'll have a little bit of problems because if you get to an exit, it doesn't mean that it's the best place to go, the best way to get to an exit. So if you, for some reason, you're doing your depth first search and you come here, you just reach an exit at 1, 2, 3, 4 steps. But you cannot stop here. You also need to test pretty much everything else to get to it. And also, let's say you had a path here, this side, and you went this way. Let's say you went all the way from 1 to 6 like this. You still cannot say that if you visit 4, you cannot really build a wall. You need to say, hey, I visited 4 and it took me 1, 2, 3, 4, 5, 6 steps. I can only visit it again if it takes me less than 6 steps to get there. But let's just use the breadth first search. So let's start coding. So what we need to do is create a FIFO. So our FIFO is going to be a list. And the list starts with the entrance and 0 steps. That's it. And second, we need to mark entrance, build wall at entrance. So maze of entrance 0 and entrance 1 equals a plus. If you remember, maybe you didn't see it here, the code here is plus are walls, 1 dots are places you can walk. And the mazes, by the way, they look like this. So yeah, this is this. So I'm just going to leave it here. So build wall at entrance and while, and now depth first search while we have a FIFO. So while FIFO, while we have stuff there, let's do, hey, pop left. So current row, current column, and current steps equals FIFO.pop 0, which is pop the first element. And now, this is the important part to make it a breadth first search. And now we go, what do? We check if it is an exit sign. So one way of checking if it's an exit sign, and I fix like the best one, we check if current row equals 0 or current column equals 0 or current row is equal to length of maze minus 1 or current column equals length of maze 0 minus 1, then return current steps. However, if the first position, which is the entrance, is by an edge, we don't want to return it. So we also need to say if current steps is bigger than 0 and everything else. So why? Because current steps equals 0 will only be at the entrance only. Everything else you need more than one or more steps to get there. So this is our condition to avoid the case of an entrance being at the edge of the map. So now, add more things to FIFO and build walls. So if, by the way, this length of maze is, and length of that, I'm just going to say length of rows and length of column is this. So length of row length of column. So now if current row is bigger than 0 and maze of, I just need to check the placed up, down, left or right, if it's a wall or if it's by the edge of the map or something. Actually, we don't need to check if our current row is bigger than 0. Can we? Or do we? No, we don't need to, because if our current row, if we were by the edge, we would have already finished. So if maze of current row -1 and current column equals a dot, so we say we do FIFO.append current row -1 and current column and current steps +1, and we build a wall. And we pretty much repeat this process for all the other ups and downs positions and left and right. Okay, if append that, so if current call -1, that, then FIFO call -1, call -1. So if row +1, +1, +1, and same thing here, if column +1, +1, that's it. And if nothing checks out, we just return -1. So I'm feeling confident about this. Let me just submit that. Whoopsie. Pop, FIFO pop 0. So it starts right, but maybe I'm just not appending what I should. Oh yeah. Cannot unpack non-iterable int object. Oh yeah, right. It's a list of a list. Submit. Wrong answer. Why? Output 1. Yeah, this is 2 because it just needs to travel all the way. Why did it output 1? Okay, let's see, why did it output 1? Solution, nearest exit. So yeah, current steps is indeed 1, and current row is 1, current column 1. Okay, current steps and current row is 0, or current call is 0, or current row equals length row. It's not true, or current call equals length call minus 1. Hmm? Length of call is length of maze 0, length 3, length row 2, length call 2. Oh, yeah, what's this minus 1 doing here? Something that survived from before. Wrong answer. Output minus 1, expected 2. Okay, let's run this. Length row, length call. Yeah, it did not return anything. Return minus 1, so why? Just gonna put a breakpoint. Let's see what happens. So current row. Okay, we add the next one, next one. Current row is 1, current column is 0, minus 1 equals point. Current column minus 1. Oh, I'm going for the opposites. Damn. Yeah, this is walking through walls. So I can't make it walk through walls. So if current call is bigger than 0 and also the same thing, current row. I think now it's good. Actually, this will fail. Yeah. I also need to check if current row is smaller than length row minus 1. Same thing. Because the initial position, the entrance, can also be on the edges, so current call just to do something so simple, there are just so many nuances. Okay, so 169 out of 194 passed. Why the hell didn't this pass? I think this is the same. Why? So we start at 1, 0, yeah. you can go to the right. And we can not go to the right. Why not? I think this is the... Yeah, that's not -1 because I already did the -1 here. Okay, great. We had good results. I'm happy. One way to optimize this a little bit is we don't need to save the current position of each one. So let's say we don't want to save the current steps, not current position. The current steps of each position. So we can delete this. So I can create a variable called steps. I can move current steps outside. And while FIFO, and then I can do something which is for something in range of the length of FIFO, and I can put this inside this. So what does this mean? So when we start, the current steps is 0 and we only have one element. So while we have the FIFO, we do all of that, but let's iterate over the FIFO, the length of the FIFO, which will be 1. So because we just have 1. So we add all those new positions that will have the steps 1. So at this moment, current steps will always be 0 until it ends this loop. And when it starts the next one, the number of steps of all of them will be 1 until we finish the FIFO. Things might be added to the FIFO in the meantime, but for the range, when we start looking at it, everything will have 1 step. Same thing for the next time and the next time. So yes, this will also work, and it's just, I think, consumes a little bit less of memory, but we have very good results. Let me just submit that and see if it works. Too many values to unpack, current call FIFOs. Okay, yeah, right, sorry. I need to remove this, this, this and that. Copy and paste it and submit. So yeah, same good results. I hope you guys liked it. Yay! I hope you guys liked it, and see you next time. Bye.